Hello everyone, welcome back to the video lecture series on engineering mechanics. In the topic friction, today we will discuss the friction on inclined plane. We will try to understand how to solve problems on an inclined plane. See, a force of 250 newtons pulls a body of weight 500 newtons up the inclined plane. The force being applied parallel to the plane. If the inclination of the plane to the horizontal is 15 degrees, find the coefficient of friction. Look at the diagram. A block of 500 newtons is resting on an inclined plane, which is at an angle of 15 degrees to the horizontal. And the coefficient of friction we need to find. The coefficient of friction will be between the contact surface of the block and the plane. And here the force is given a 250 Newton force, a pull is applied to the body as shown in figure like this. Now it is trying to pull the body up. The body is resting on inclined plane. The angle made by the inclined plane with respect to horizontal is 15 degrees. This is the data given, and the coefficient of friction between the plane and the body is to be found. Now come to the solution. Draw the free body diagram of the block. See, the body is resting on a inclined plane. Weight always acts vertically downwards, and normal reaction will be always perpendicular to the contact surface. The normal reaction will be always perpendicular to the contact surface, and weight always acts vertically downwards. The angle between these two will be always equal to the inclination of the plane. Why? Because see, this weight is perpendicular to the horizontal and normal reaction is perpendicular to the inclined plane. So the angle between horizontal and vertical is 90 degrees. The angle between inclined plane and normal to the plane is 90 degrees. Okay, by using the triangles here we can find the angle. See, let us see how to find the angle here once. See here, the weight acting vertically downwards, and this is horizontal, and plane is at an angle of 15 degrees, and this is weight. Our normal reaction is perpendicular to the contact surface. This is normal reaction. Now look at the diagram. This is 90 degrees and this is also 90 degrees. So here it is, the plane is making 15 degrees with horizontal. From this triangle, the angle here, the plane made by this vertical, the angle of plane with vertical we can find. So here it is, in a triangle the total angle is 180. So 180 minus this one, 90 minus 15. 180 minus 90, it is 90 minus 15. 90 minus 15 is equal to 75. Here it is 75 degrees. And we know that the normal reaction is perpendicular to the plane. So here the total angle between these two is 90, and the angle made by the plane with vertical up to this portion it is 75. So the remaining angle here is 90 minus 75, which is equal to 15 degrees. So in this way we can calculate the angle, and or otherwise we can take it directly. By practice we can take it directly. the angle between the weight and normal reaction will be equal to the angle of the plane, 15 degrees. Now a force of 250 newtons is applied parallel to the plane in upward direction. If the body is tending to move in upward direction, the friction will be in downward direction at the contact surface. Friction always acts in opposite direction to the motion of the body. Here the body is tending to move in upward direction along the plane, therefore the friction will be in downward direction parallel to plane or along the plane. Now draw the force diagram. This is free body diagram. Now draw the force diagram, show only forces. So 250 Newton force is acting parallel to the plane, a normal reaction is perpendicular to the plane, and friction is again along the plane. See here, the applied force, friction are in opposite direction and they are along the plane or parallel to the plane, and normal reaction is perpendicular to the plane. Now coming to the weight is acting at 15 degrees to the normal reaction. The weight always acts vertically downwards, but here its angle with respect to normal reaction is 15 degrees. Right? Now, while resolving the forces on inclined plane, instead of resolving the forces horizontally and vertically, we will resolve the forces perpendicular to plane and parallel to plane. Just like when the body is resting on a horizontal plane, we will apply static equilibrium equations like this: sigma h equal to 0 and sigma v equal to 0. These two equations we can apply for the same case, for this case also. But the problem is, if you take horizontal and vertical, we need to resolve 250 newtons into both horizontal and vertical components, and we need to resolve the normal reaction also into two components, vertical component and horizontal component, and the friction also we need to resolve horizontally and vertically. To overcome this problem or to avoid this resolution of too many forces, we will resolve the forces into two mutually perpendicular directions. Those are, one is parallel to plane, the other one is perpendicular to plane. Let us understand the advantage of resolving the forces parallel to plane and perpendicular to plane when solving inclined plane. The advantage is, no need to resolve 250 newtons because it is along the plane. No need to resolve friction because it is again in the same line or parallel to the plane, and normal reaction is also perpendicular to the plane, no need to resolve, and only weight is acting at an angle of 15 degrees to the normal to the plane. So therefore only weight can be resolved into two components. That's why in inclined plane problems, generally we will resolve forces or we will apply static equilibrium equations in this way. Let us apply static equilibrium equations. Sum of forces parallel to plane equal to 0. Sum of forces parallel to plane equal to 0. Sum of forces acting along the plane upwards is equal to along the plane downwards, or otherwise we can take sign convention like this: upward positive, downward negative. Therefore the sum of forces parallel to plane is equal to 0. So if you substitute the values in this equation, 250 minus f minus 500 sin 15 is equal to 0. 250 is parallel to plane, friction is also parallel to plane in opposite direction, and we are resolving weight into two components. Here the perpendicular to the plane component is 500 cos 15 and parallel to plane component of weight is 500 sin 15. Now 250 minus F minus 500 sin 15 is equal to 0. F is equal to 250 minus 129.41, that is 500 sin 15. So from this expression we can calculate the value of friction. The friction value is 120.5 newtons. Now resolve the forces perpendicular to plane and equate to 0. We will apply static equilibrium equations to the inclined plane problems like this. So we will resolve parallel to plane and perpendicular to plane and equate to 0. Now sum of forces perpendicular to plane equal to 0. Let us see how many forces are acting perpendicular to plane. Normal reaction is acting perpendicular to plane in upward direction. So for this problem I will consider upward positive and downward negative. So N is acting in the upward direction, and the force 500 cos 15, the perpendicular to plane component of weight, is balancing the normal reaction. It is acting in opposite direction to the normal reaction or in the downward direction. Now apply the forces in this equation. N minus 500 cos 15 is equal to 0. N is equal to 500 cos 15, and the value of N is given by 482.96 newtons. Now from the first equation we got the value of friction, and the second equation we got the value of normal reaction. By using these two we can calculate the quotient of friction. We know that the quotient of friction is given by quotient of friction mu is equal to F by N, limiting friction divided by normal reaction. Now substitute the value of F and N in this equation to find the quotient of friction. So mu value is given by 0.249. It is unitless parameter. So this is how we can find the quotient of friction or any unknown forces, or what is the minimum force required to keep the body under equilibrium. If friction is given, we can calculate. Now look at another problem to understand the concept of friction on inclined plane. A body of weight 60 kilonewtons is on the point of motion down rough inclined plane when supported by a force of 24 kilonewtons parallel to the plane. The same body is also on the point of moving up the same plane under the action of 36 kilonewtons applied parallel to the plane. Find the quotient of friction. Here two cases are given. In the first case, the body is at a point of moving down. When the force is applied, 24 kilonewton force is applied, it is at a verge of moving downwards. The weight of the body is 60 kilonewtons. A 60 kilonewton body under the action of 24 kilonewtons force, which is acting parallel to plane, the body is at a point of moving down. Its tendency is moving in downward direction. The same body, same plane. When the force of 36 kilonewtons is applied on that, then the body is tending to move in upward direction. By using these two cases, find the quotient of friction between the block and the plane. This is the problem, this is the case. Let us try to solve this problem. Look at the diagram. See, this is the diagram for case 1. When 24 Newton force is applied, parallel to plane, the 60 kilonewton block is at a point of or under the tendency of moving down. So in this case, the tendency or the motion is the tendency to move in downward direction. And in the second case, when the force is increased to 36 kilonewtons, now the tendency of the body is to move in upward direction. From 24 kilonewtons to 36 kilonewtons, the body is at rest. It is under rest. And at 24 kilonewtons, the tendency of the body is to move downwards. That means if this force is reduced to 23.9 or any value less than 24, the body moves downwards. If we increase the force more than 36 any value, the body moves along upward direction. Now by using these two conditions, find the quotient of friction between the plane and block, quotient of friction between the inclined plane and the block. Okay, let us solve the problem. First, draw the free body diagram for the first case. See, the block is resting on an inclined plane. In this case, the inclination of the plane is also not given. We have to find it. The weight always acts vertically downwards, and the normal reaction will be always perpendicular to the contact surface. We know that the angle between weight and normal reaction will be equal to the angle of the plane. We have seen how to calculate that in our previous problem. Now, a force 24 kilonewtons is applied parallel to the plane, and the tendency of the body under the action of 24 kilonewtons is to move downwards. Therefore, the friction will act in the upward direction. The friction always acts in opposite direction to the motion of the body, not to the applied force. Here in this case, the applied force is in upward direction, but the tendency of the body is to move downwards. That's why the friction we need to consider in opposite direction to the motion of the body, not to the applied force. Right? Now, draw the force diagram. 24 kilonewtons acting parallel to plane, and normal reaction is perpendicular to plane, and friction is acting along the plane, and its direction is upward, and weight always acts vertically downwards, and its inclination with normal reaction or perpendicular to plane is theta. Now we will resolve the forces parallel to plane and perpendicular to plane to check the static equilibrium equations. See, the body is under equilibrium. That means sum of forces parallel to plane is equal to 0, and sum of forces perpendicular to plane is also equal to 0. Then only the body will be under equilibrium. Now take the first condition. Sum of forces parallel to plane equal to 0. Let us find how many forces are acting parallel to plane. Here 24 kilonewtons is parallel to plane. F is also parallel to plane in the same direction of 24. Now resolve the weight. The weight component perpendicular to plane is 60 cos theta, and its component along the plane is 60 sin theta. I am assuming upward, along the plane upward positive, and along the plane downward is negative. Now apply static equilibrium equation. 24 plus F minus 60 sin theta is equal to 0. 24 and F both are in the same direction, and 60 sin theta alone is in opposite direction along the plane. So therefore 24 plus F minus 60 sin theta is equal to 0. From this, F is equal to 60 sin theta minus 24. Take it as equation number 1. Now second condition is sum of forces perpendicular to plane equal to 0. Let us see how many forces are acting on the body perpendicular to plane. See, N is normal reaction is perpendicular to plane in upward direction, and 60 cos theta is perpendicular to plane. The weight component in the perpendicular direction, 60 cos theta, is acting in the direction perpendicular to plane but in downward direction. Here the sign convention for perpendicular components is, see, perpendicular to the plane upward is positive, perpendicular to the plane downward is negative. Now substitute in this equation. N minus 60 cos theta is equal to 0 because two forces are there. One is acting towards positive and other one is acting towards negative. N minus 60 cos theta equal to 0. N is equal to 60 cos theta. This is equation number 2. Now we know that already quotient of friction is equal to F by N. So substitute F by N in this equation. See here, F is equal to mu N. F is equal to mu N. Mu is quotient of friction, N is normal reaction. We have the equation for F. F is equal to 60 sin theta minus 24 into mu into N. Substitute F and N values. This is equation number 3. See, F is 60 sin theta minus 24 and N is 60 cos theta. So F equal to mu N. This is equation number 3. Now consider the second case. Draw the free body diagram for the second case. Weight always acts vertically downwards. The weight is the same block. A normal reaction will be always perpendicular to the contact surface. Now the force is 36 kilonewtons here. It is acting parallel to plane. And now under the action of 36 kilonewton force, the tendency of the body is to move upward. If the body is tending to move upward, the friction at the contact surface will be downwards, because friction always acts in opposite direction to the motion of the body. So here the friction will act in the opposite direction. Now draw the force diagram. 36 kilonewton force parallel to plane. Normal reaction perpendicular to plane. Friction is parallel to plane in downward direction, and weight always acts vertically downwards, and here it is acting vertically downwards, but its inclination with the normal to the plane is theta. Normal to the plane is theta. Now resolve the forces parallel to plane and perpendicular to plane and equate to 0. Sum of forces acting parallel to plane equal to 0, because the body is under equilibrium. Sum of forces parallel to plane equal to 0. Now look at the forces acting parallel to plane. 36 kilonewton is acting parallel to plane. F, the friction, is acting parallel to plane in the downward direction. Now the weight component. Find the components of weight. So weight component in perpendicular to plane direction is 60 cos theta, and its component along the plane is 60 sin theta. Right? Now apply the condition. 36 minus F minus 60 sin theta is equal to 0. See here, only 36 is acting towards up along the plane, and remaining two forces are acting towards down along the plane. So here, by using the sign convention, 36 minus F minus 60 sin theta is equal to 0. Now apply. Now find F. F is equal to 36 minus 60 sin theta. This is equation number 4. Now sum of forces perpendicular to plane equal to 0. So how many forces are acting perpendicular to plane? Look at this. Normal reaction is perpendicular to plane and it is acting upward. And 60 cos theta is acting perpendicular to plane and its direction is downwards. So by using this sign convention, upward plus and downward minus, substitute in the condition. So n minus 60 cos theta is equal to 0. N is equal to 60 cos theta. This is equation number 5. Already we know that mu is equal to friction by normal reaction and F equal to mu n. Friction is equal to mu, quotient of friction into normal reaction. Now substitute F value and N value in this equation. F equal to 36 minus 60 sin theta. N is equal to 60 cos theta. the value of f from equation number 4, the value of n from equation number 5, substitute here. So 36 minus 60 cos theta is equal to mu into 60 cos theta. This is equation number 6. If we observe the equation number 3 and equation number 6 carefully, see, this is equation number 3. 60 sin theta minus 24 is equal to mu into 60 cos theta. And the equation number 6 is given like this. 36 minus 60 sin theta is equal to mu into 60 cos theta. In these two equations, the RHS is same, right hand side is same. That means 60 sin theta minus 24 is equal to 36 minus 60 cos theta. See, 60 sin theta minus 24 is equal to 36 minus 60 cos theta. By solving these two equations, we can find the theta value, the angle of inclination between the horizontal and plane. Let us solve it. So, I am taking sin theta terms towards left side and numerics towards right side. 60 sin theta plus 60 sin theta is equal to 60. So, this is equal to 60 into 2 sin theta is equal to 60. So, 120 sin theta is equal to 60. Sin theta is equal to 60 divided by 120, which is equal to 1 by 2. Theta is equal to sin inverse 1 by 2, which is equal to 30. The angle made by the inclined plane with respect to horizontal is 30 degrees. Now, by using this value, theta value, by substituting this theta value in any one of the equations, either in equation number 3 or equation number 4, we can calculate the quotient of friction. So, substitute theta value 30, theta equal 30 degrees in equation number 3 or 6, any one of the equations. So, here I am substituting in equation number 6, substitute theta equal to 30 degrees. So, 36 minus 60 sin 30 is equal to mu into 60 cos 30. So, 36 minus 30 is equal to mu into 51.96. 60 cos 30 value is 51.96. Therefore, mu is given by 6 divided by 51.96. The mu value, the quotient of friction between the contact surfaces, the quotient of friction between the block and the inclined plane is 0.115. This is how we can find the unknown values or we can solve the problems on friction on inclined plane. Thank you.